Good evening, everyone. Today we're going to do a couple more study questions for the video. Um, According to my score, I did pretty well, so I think that I actually get this one. Pretty happy about that. Hopefully everyone else is doing the same. If not, keep practicing. You'll get it. So the first question, if you had a rock that originally contained 1,200 grams of the parent isotope for an isotope pair that has a half-life of 1.5 billion years, how old is that rock if 300 grams of the parent remain? And then bonus points for how many grams of parent will be left after 4 half-lives and years. So I had already set up my little thing here. So all will be pretty much 0 at the beginning, 0 half-lives, 0 million years. Proportion of the parent ratio will be 1, daughter 0. Amount of the parent will be 100%, daughter will be 0%. So we got 1,200 grams, so 0 grams of that. And then, so 1.5 billion, so actually 1,500 million years, 1 half-life. So at this point, half the parent will remain, half the daughter will remain. So we're at 50%, 50%. So at this point, half of 1,200 is 600 grams. So we got the remaining 600 grams will be for the daughter. So now 3 billion years or 3,000 million years. Should change that. That'll be 2 half-lives. So at this point, we're going to be at a quarter of the parent, which makes it 3/4 daughter. Again, 25% will be the parent and 75% will be the daughter. So we have 300 grams left of the parent, which then the remainder will be 900 grams for the daughter. So our first question here, how old is the rock? There's 300 grams remaining. So we'll have 300 grams remaining, be 3 billion years or 2 half-lives. So 3 billion years. Oh. 2 half-lives of the isotope. So then the bonus question, how many grams of the parent will be left after 4 half-lives in years? Go back in here. So at 4,500 million years, we're at 3, which would be 1/8 of the parent, so 7/8 of the daughter. Our percentage is going to be 12.5. 12.5 minus 100 is 87.5. We're at 150 grams of the parent because we just cut it in half again. So the remainder of that is 1050. So 4 half-lives is what we're going for. So 6 billion years, aka 6,000 million years. 4th half-life, so will be 1/16 of the parent, so 15/16. I didn't change that one, hold on. 15/16. So at that point, we're going to be 6.25% parent and 93.75 daughter, which gives us 75 grams because we cut it in half again. And that one will be 1125 grams of the daughter. So we get into our question, how many grams of the parent will be left? So there'll be 75 grams left of the parent. So, like I said, I actually understood this so I'm completely amazed. But if anyone has questions, I can help maybe. Probably not, but maybe. So hopefully y'all did good. Thanks.